Set B, number 1, the figure below is based on a representative sample of married couples in New York. The graph shows the average income of wives given their husband's income. With 102 couples, the husband's income was in the range $1,000 to $5,000. For those couples, the wife's income ranged $15,000 as indicated by the point 2,500, 15,000. With 58 couples, the husband's income was in the range of $5,000 to $10,000. For those couples, the wife's income ranged $18,000 as indicated by that point, and so forth. The regression line is plotted too. True or false? There is a positive association between husband's income and wife's income, which means if husband's income goes up, wife's income also goes up. True or false? True. The line is sloped up. So it's true. You guys are looking at me like I messed up. What did the back of the book say? It said true. Okay, good. And C, oh wait, how can you explain the association? Why, in a relationship where the husband makes more money, does the wife also make more money? And in relationships where the husband is below average in income, the wife's income is also below average. Why might that happen? Any ideas? If I would have asked you, you probably would have said, if the husband makes a lot of money, the wife doesn't. And if the wife makes a lot of money, then the husband doesn't. But that's not what we're seeing. Husbands who make a lot of money, who make more than average, have wives that also make more than average. And husbands who make below average have wives that also make below average. Why might that happen? Any ideas? Okay, good. It might be education level. A man who goes to doctorate school is probably quite likely to find a girl who is also in college. Okay? And men that do not hang out with people who make a lot of money tend to marry women who also don't make a lot of money. It's probably a social thing. Where did you meet your wife? Where did you meet your husband? Okay? It might also have something to do with their thoughts on education, or not of income. Husbands who are content to have a job they love that doesn't make a lot of money are probably more likely to marry a woman that has the same ideals. And a man who puts a lot of value on making a lot of money is probably more likely to marry a woman who has the same thought. She needs to make a lot of money. Okay? And there could be other things at work. It doesn't really tell us. C, if you use the regression line to estimate wife's income from husband's income, would your estimates generally be too high, a little too low, or just about right? For the couples in the sample with husband's income range 65 to 80,000. Oh man, I hate it when it does this. Okay, let's try it this way. Dang it. Hang on a second. Oh, it's not even on. That would be a problem. Sorry, guys. Now I have to move everything back over. All right. Now let's see if it works. Yep, that's a problem. All right. I don't know why my camera is not working. Actually, let me try. Hey, now we're rocking. Okay. So finally, let's look at this scatter plot. So looking at this scatter plot, what do those numbers mean? Every dot has a number next to it. What does that number represent? How many people have that number as its average? So, for instance, the very left dot says 102. So there were 102 people whose husband's income was between like 0 and 5,000. And the average of the wife's income was about 15,000. Okay, what do we call that when instead of graphing people, we graph averages? What's the, starts with an E. What's the phrase when we take a scatter plot and we smash it down to a single point? Ecological data. Okay, what happens to the R value when you plot ecological data? The R value, so all of that spread gets smashed down to a single number, and the R value goes up. So this has a pretty tight, I mean, that was not drawn very well, but with the exception of a couple numbers, it has a pretty tight football, more like a frisbee. So the R value would be like 0.8, maybe 0.7 with those weird numbers off to the side. But if we expanded all of those points, then our R value is going to go way down, and we're going to get something much more egg-shaped. Okay, so this question asks, if you look at the people from the men from 65 to 80,000, so if we look at this column here, and I'm going to pull this down a little bit and pull that down a little bit. Okay, our best guess for the women's value is right there. Is that number going to be too high or too low from the original? Well, we have to compare it to the egg-shaped version. So in our egg-shaped version, and I didn't draw it very well, but that average, because the R value is smaller, when I go SD to the right and I go SD up and then I chop it, when R value is bigger, I'm going to do a bigger chop. So this might be the chop for the high R value, but this is going to be the chop for the low R value. So we would expect our answer to be higher than it actually is because we have an R value that is larger than it actually is. Okay. So it says, would your estimate be a little too high or a little too low? I would say it will be a little too high because the true graph has a smaller R value, and that smaller R value is going to chop more off of our SDY. And the correct answer is going to be lower than the one that we were given. So our answer will be a little too high. Okay. What number? What did it say? About right? Did I read it wrong? If you're... what's the average? If you use the regression line to estimate wife's income from husband's... Oh, that's because we're below average. Okay, I'm sorry. We're on the other side. So this is the average there. We're on the other side of the graph, so instead of going up, we're going down. That would explain it. Sorry, I did the problem backwards. Okay. And then number 4, 3. Below are 4 scatter diagrams, each with a solid line and a dashed line. For each, say which is the SD and which is the regression y on x. Okay. I tried to take a picture of it. It won't do it. Dang it, I missed. There we go. Okay. So for this first one, we draw the football. Which one of those is the SD line? The dashed one is the SD line. And so this line here is the regression line. We call it the y on x because the graph, the y values are dependent on the x values. Okay. For the next one, we draw the football. Which one is the SD line? The dotted one, the dashed one, and the other is the regression line. So if your R value is positive, the slope of the regression line is what compared to the slope of the SD line? The regression line has a slope that is what compared to the slope of the SD line? So this is the SD line, and the slope of the regression line is smaller, shallower. When we have a negative SD line, so here's a negative SD line, then the regression line is actually steeper. So that's one kind of hint to help us solve this. But there is a third line that we'll talk about later. Okay, we draw our football there. Which one is our SD line and which one is our prediction line? Well, it's a circle, so they both cut the circle in half. So which is the SD line? The dashed one, why? If you have a graph that's a circle, can you predict what's going to happen for any particular x value? No. You can't predict anything. The reason you can't predict anything is the R value is 0. So the regression line is horizontal. Okay, and then for the other one, which one is the SD line? Let's say the solid line, and then did they throw us a I didn't draw that very well. Sorry. No? Did somebody look this up in the back? Are they trying to confuse us? I would say this is the SD line, and then that line is wrong. Is that what it said in the back? Okay. Yeah, there is no... They graphed the SD line, but they did not graph the Y on X line. This is a different line that we haven't learned about yet. Okay.